3 of the algebra. I almost said algebra 3, but that's next algebra. Okay? So today, we're going to solve two-step equations again, which means we've got 2 mathematical operations to do first. We'll talk about which one we have to do first, which one we have to do second, all that good stuff. Tomorrow, we're going to have an activity in class. It's only a 2-mod day tomorrow, so we'll have a fun activity, a little sorting, a little solving, a little good stuff action going on. Wednesday, looks like we're going to distribute and solve. So that's going to be an extra step. So now we'll have 3 steps that we can do there. And then we'll do that again on Thursday. And then this week, Friday, we're going to take a formative in class on Friday. Good stuff. Okay? So, a couple of warm-up here problems for you to do up at the top of your D3 warm-up section on your notes. Go for it. All right, in letter A, what am I going to do first? Okay, you're a liner?
Yes, sir.
Okay. Okay. So what am I going to do first? What am I going to do first? Subtract 3 first, because remember we do addition and subtraction in solving equations first. So I'm going to subtract 3 because it's plus 3. Okay. All right. So then these cancel each other out, leaving me with 4x equals 7. Then what? Divide 4 on each side. Does 7/4 reduce? Does 7 divided by 4 reduce? Does it reduce? No, there's no factor that goes into 7 and 4, so we are going to leave it as 7/4. Okay? No mixed numbers. Why do we not want mixed numbers? Oops, I jumped ahead of what I was supposed to do. Why do we not want mixed numbers? Do we know? What's next? What do we got to do next? We got to check it. Okay? So in order to check it, we got to plug it back in. So if we had it in a mixed up number form, it would be harder to plug back in. So we're going to leave it as a improper fraction. And we're going to plug it back in. 4 times 7/4, then plus 3. 4 is like 4/1. Okay? What can I do with the 4 on top and the 4 on the bottom? I can cross them out, right? Because one's on top, one's on the bottom. So these cross out as long as it's top and bottom. Leaves me with what here in this first fraction? Just 7, right? And what is 7 plus 3? 10. And 10 is equal to 10. So now that we've done our work, we've checked our work, now what can we do? Now we can brag about our work. I jumped ahead earlier, and I bragged about our work before we even checked it to make sure we were right. Okay. Good times. Okay. In letter B, what's the first thing that you are going to do? Okay, if you're a liner, you can draw the line. Yep, I'll do this one without the line though, because not everybody's a line type person. Okay, so what's the first thing that we're going to do? Divide both sides by -8. Because these cancel each other out then. Right side, so the far side, what do we get? What do we get? X. We just get X. We don't get 0x because 0 times anything is 0. So we get X over there. Right side, what do we get? What do we get on the right side? What do you got? 2? Do we all agree with 2?
Wait, no. Negative.
Do we now agree with negative 2? Not a lot of agreement. Do we agree with 1/2? 1/2 is the new number on the floor. Not a lot of agreement with positive 1/2. Negative 1/2 is now the number on the floor. Do we agree with negative 1/2? We should agree with negative 1/2 because this is negative 1/2. Now, I'm going to go back to you said your very original one. No, listen to me. Your original one you said was 2, right? Yes, you did. Okay? Right? So if I would go back to that original one that you gave me, and you said it was 2, what is negative 8 times 2? Negative 16, right? It is negative 16 equal to positive 4. No, so your check should have caught that wrong answer. Okay? Which is why we do the check. Okay? So that's not going to work. So now let's check our actual answer of negative 1/2. Negative 8 times negative 1/2. So this is like negative 8 over 1. If I multiply across the tops, negative 8 times negative 1. 8. 1 times 2 if I multiply across the bottoms. 2. 8 divided by 2 is
4.
Positive 4, and positive 4 is equal to positive 4. So that check step helps us out because it tells us if we're right or if we're wrong. But if you don't do the check, then you'll never know. Then you're leaving it up to chance. Okay? Me, I'd rather know that I'm right. Okay? Good stuff there. All right. What's our goal? Our goal in every equation is to do what? Get the variable all by itself. Okay? Write that down again. Yes, I know. This is the 3rd day of Unit D. This is the 3rd time we've written it down. And we're going to keep writing it down until we got it quotes memorized. What's the golden rule of algebra? Somebody other than Jesse. Somebody else. What's the golden rule of algebra? If you don't know, flip your page over and look back. What do you got? Whatever we do on one side, we got to do on the other, right? Okay? So the golden rule of algebra states that whatever we do on one side of our equation, we've got to do on the other side. And the key word there is must. Okay? Whatever we do on one side of our equation, we must do on the other side of the equation. We'll pause here so you guys can get that written down. Give me 2 opposite operations in math. Multiplication and division are opposite operations in math. Yes. Addition and subtraction, even though I can really want to hook around their mouth like that. You know what I mean? Huh? Addition and subtraction are the other 2. Now remember, we're developing some processes to figuring out how to do solve these equations. We're not quite ready. We'll be ready on Wednesday to give some more another step. But remember that our 2 steps that we have are actually step number 4. The first thing we do is we first clear off any adds and subtracts, okay? And we use opposite operations in order to do that. So like we did in the first example today, if we were adding 3 in the problem, we subtracted 3 to clear it. Yes. Okay. Then after that, then the last thing we do is we clear our multiplication and our division, again using opposite operations. So if they're being multiplied, we divide. If they're being divided, pause again so you guys can go. All right, let's do one. Let's actually do a couple here now. All right. So in number 1, what's my variable? N. So I got to get n by itself, right? Okay. So what is being done to n by the 5? It's being subtracted. So what's the inverse? What's the opposite of subtraction? Addition. So I'm going to add 5 to both sides. That makes those go away, leaving me with just n. Negative 9 plus 5, which way is plus? Up, right? Okay. So if we go up 5, where am I going to end? Negative 4. Okay. Check our answer. Negative 4 minus 5. Now I'm going to start at negative 4. I'm going to go down 5, and that's going to put me to negative 9, which is what I needed it to be at. Now, let's skip down to number 3. What would we do first in number 3? Subtract 2 from both sides first, because we clear our adds and our subtracts first. Okay. So if I subtract 2 from both sides, then that's going to leave me with 3n. Those are going to cancel each other out, equaling 7. Okay. Then what am I going to do? Divide 3 on both sides. Okay. That cancels those out. And that leaves me with n being 7/3. If I plug that back in, (3 over 1 times 7 over 3, those 3's cancel each other out, leaving me with just 7. 7 plus 2 is 9, and 9 is equal to 9. Again, that check shouldn't take you very long. It should take you more than 30 seconds to check it, but it's a very important check. Just because we haven't done one in a while, let's look at number 4. Let's do number 4 together. Okay. What are we going to do to get rid of the y? Well, so first off, what's our variable? Y. Okay. What operation is 3 doing to y? It's dividing. Okay. So how am I going to clear the 3 from the y? We're going to multiply because it's opposite, so we're going to multiply both sides here by 3. That's going to clear that out, leaving me with y. Negative 5 times positive 3. Why negative 15 and not 15 as Jesse so rudely said? Positive times negative. Signs are opposite, so we have got to be negative. They are not the same. Okay. Then we check it. Negative 15 divided by 3. Is it going to be positive or is it going to be negative? It's going to be negative because the signs are different. 15 divided by 3 is negative, so 5, so then that's going to be negative 5, which is what we needed it to be. So now we can be proud of our answer. Okay? Ooh, I like it. You try 5 and 6 right now. All right, let's talk number 5 here for a second. What are we going to do first? Do we agree with add 9 to both sides? Well, is 9 positive or is 9 negative? Right now, as it looks right there.
Minus
It's positive. So what would 9 plus 9 be? 18. That's not 0, so it doesn't make it go away. So let's subtract 9 from both sides. Yes. Okay. Okay. So if I subtract 9 from both sides, then these go away. 9 minus 9 is 0. And that leaves me with negative d over there equaling 3. Now, when I was walking around the room, some of you said, all of a sudden scrambled because I said up here that negative d doesn't have d by itself. Okay? What does negative d actually mean? It's what? Negative 1 d's, right? So negative 1 times d. Okay? So we want d by itself. So I either have to, no, can't add 1. I can divide by negative 1, okay? Or, because this is a special case, because it's negative 1, I can also multiply both sides by negative 1. But I'm going to stick with the dividing by negative 1, because then we're doing what our steps are, because we said we would divide by whatever that coefficient is out in front there. Okay? So negative 1 divided by negative 1 makes me my positive. 3 divided by negative 1 is negative 3. Now again, if you tried positive 3 back into your equation, you would have gotten the wrong answer if we would have checked it. Okay? Because 9 minus positive 3 is 6, and 6 is not equal to 12. You got what? Nine minus a negative is like plus. 9 plus 3 is 12, and 12 is equal to 12. So now we can be excited and brag about our answer. In number 6, what did we do first? We subtracted 7 from both sides first, because that cancels that out. That leaves me then with positive 3 equals x divided by 4. My next step is going to be to multiply both sides by 4. That cancels these out. That leaves me with 12 equals X. When I go and check it, 12 divided by 4 is 3. 7 plus 3 is 10. And 10 is equal to 10. Yeah. Let's do a word problem. We haven't done a word problem in a while. Okay. Let's do a word problem. Ted, what's the first thing we got to do in a word problem?
Read it.
We got to read it. Okay? So Ted spent half his weekly allowance on some clothes. To earn some more money, his parents paid him $10 to shovel the driveway. What is his weekly allowance if he ended the day with $19 in his pocket? Okay? What are we trying to find?
How much he makes for every, or no, how much he makes for every.
So we're trying to find his what? Weekly allowance. We can say it in 2 words. Yep. Okay? So X is going to be what we're trying to find, which is Ted's weekly allowance. Okay. 2 questions that I always ask now. 1, what's the unit? What's our answer going to be given in? Like in the final stages, what is it going to be? Like what's the label on our answer going to be? Money, so that means it's going to be like dollars, right? Okay. My second question that I always ask myself is, can I have decimals?
Yes.
How many decimals could we have? 2. 2, because it's cents. Cents is $2, 2 decimal places, right? Okay. So we could. So would a fraction make sense here?
Yes.
In money?
Yes.
You just said that the money is going to be the answer, right?
Yes.
So would a fraction make sense here?
When
you go to the store, do they charge you $7 7/8 for a shirt? Serious question. When you go to the store, do they put their money on the price tags? Is it in fraction form or is it in decimal form? It's in decimal form. So this answer would not be given in decimal form, or excuse me, in fraction form. We would make it be a decimal, if it is one. Okay? Okay? Now we got to come up with an equation. So we got to go back and we got to reread the problem. Ted spent half his weekly allowance on some clothes. How do I represent half of my weekly allowance? I thought you had it. I thought you were raising your hand. How do I represent half of my weekly allowance? What do you got? I got to represent half of my weekly allowance. What's my weekly allowance?
19.
What's my weekly allowance?
10.
What's my weekly allowance?
I don't know.
X is my weekly allowance. It's the only thing that we've done in the problem so far. Okay? X is my weekly allowance. So how am I going to represent, now Nora, how am I going to represent half of it? What am I going to divide by 2? What am I going to divide by 2?
19.
What's my weekly allowance? What's my weekly allowance? The only thing written on the board. X. So how am I going to represent half my weekly allowance? X divided by 2. We have to come up with an equation first. We can't just guess and check. X divided by 2 comes out of that first sentence. Okay? Then, she's going to get more money. So how do I represent more in math? Plus. More is going to be plus. How much more is his parents giving him? $10. Okay? So $10 is how much more he's getting. Okay? At the end of the day, how much money is in his pocket? $19. That is your equation. You have to come up with an equation first, because otherwise you've got nothing to solve. Okay? Now, we have our equation. How are we going to go about solving said equation? We're going to subtract 10 from both sides. That's great. We're still not there yet. That gives us x divided by 2 equals how much? 9. Now we're going to multiply both sides by what, Mark? By 2. That's going to give me x equals 18. So what is my final answer? No.
Oh, you have to check it.
No. We're still not there yet. What is my final answer? $18 is my answer. Okay? So now we're going to go check it way back up here in the original problem. Okay? So if his weekly allowance is $18, what's half of 18? 9. So now he's got $9. Then his parents gave him $10 more. So how much money does he have? $19, which is how much he ended up with. Okay? Okay? Word problems aren't that tricky, but they just involve more work because you have to create the equation first, then you have to solve it. You're not just given the equation. Okay? Good stuff. I don't think there's a